Hello, I'm Mike Wheeler, and this is week 9 of our safety and leadership course. This week we're going to talk about electrical grounding and electrical tool safety. Um, Objectives for this: we want to define what electrical grounding is. We've talked about why it's important. We're going to talk about that some more. Explain the importance of electrical grounding from a safety perspective. Explain the purpose of a GFCI, a circuit breaker, and fuses. List the electrical safety features designed into modern tools. So electrical grounding, we've already talked about how circuits are grounded, but why is proper grounding such a critical safety issue? So what is grounding? Grounding is literally an electrical connection to the earth. It may not look like it's there, but you know the third prong on your outlet, it ends up connected to actual ground somewhere. Electricity is always trying to get to ground, and it will always take the path of least resistance to get there. Okay, so why are grounds important? With a ground connection, if there's a problem with the tool, which would be an equipment grounding issue, or a short in the wiring, which would be a circuit grounding issue, the electricity gets loose, and this loose electricity will take the ground path to earth, usually tripping the fuse of the circuit breaker in the process, and this is what's known as a low resistance ground fault. Low resistance in that there's very little resistance to that electricity going through the ground. Without a good ground connection, that loose electricity is going to take the easiest path. Again, it's going to do the same thing. It's going to take the easiest path to earth, which is called a shock or electrocution if that path happens to take it through you. You never want to be the best available ground path. And how we keep ourselves from being that is we make sure that the grounding on our tools is correct. And common hazards that can either make the situation worse, or common stuff we see in industry, working in wet areas with wet clothing. If you're wet, your resistance to electricity gets lower, so you're a much better conductor, so you become a much better available ground. Metal electrical conduit, that's like one of the things you always see in industry is there'll be wires inside this electrical conduit, the wire chafes, exposes wire on the inside, and then electrifies the conduit. If it's properly grounded, it will trip the circuit breaker, blow a fuse, or something like that. If it's not, that is a huge electrocution hazard. Exposed wiring for the same reasons. And then metal frame machinery and metal case tools. There's not a lot of metal cased hand tools out there anymore. We'll talk about that in a little bit. But metal frame machinery, most of that stuff, if the ground is not connected correctly, the frame ends up being electrified. So we want to be really careful with that. So ground fault circuit interrupters. One common way to protect ourselves from ground faults is through GFCI outlets. GFCI is what ground fault circuit interrupter stands for. So ground faults are classified as either low or high resistance. And a low resistance ground fault, like we just talked about with fuses and circuit breakers, the lack of resistance allows a lot of current to flow. This high amount of current is usually enough to trip the circuit breaker or blow the fuse. In a high resistance ground fault, the electrical flow may not be large enough to trip a circuit breaker. So in those cases, a GFCI provides the required protection. And GFCIs are much more sensitive to current changes and imbalances than fuses or circuit breakers, and can be tripped by a much lower current, like 5 milliamps, and they can do it very quickly. And we remember back about how many, like it takes 50 milliamps to stop the heart. So ideally, GFCIs are tripping much before we get to that danger range. And you probably have GFCIs in your house. They've been putting them in any kind of modern construction for probably 30 years now. In your kitchen, in your bathroom, just so if you got electrical stuff, hair dryer, curling iron. I don't know why you'd have a toaster in the bathroom, but totally you could have a toaster in the bathroom, I guess. Around any kind of water, they put GFCIs in so that if your toaster falls in the bathtub, it doesn't electrocute you. They also make portable GFCIs. That is just a 2-foot mini extension cord with a GFCI in the middle of it that you can plug in between the wall and your extension cord or your tool. And they're a great thing to have in your toolbox if you end up working out in the rain with electrical tools. And most GFCIs, if not all of them, have testers on them, a push button tester to make sure they work. Check that every time you plug one in. Circuit breakers and fuses. Circuit breakers and fuses are electrical safety devices that provide overload and overcurrent protection. So electrical circuits are designed to operate at specific current levels. So if you've got a 120 volt 50 amp circuit and you plug in a tool that's 120 volt but it's a 20 amp tool, so it'll pull 20 amps, the fuse or circuit breaker is designed to trip to keep the overloaded circuit from overheating the wiring, possibly causing fire or shocking somebody. Fuses are generally single use. Circuit breakers can be reset. The important thing to remember about fuses and circuit breakers is that they respond to a problem. Don't just reset a circuit breaker or replace a fuse without investigating what the problem is. Some of them are pretty simple. Like if you're in your garage, your air compressor is running, and the circuit breaker pops when you fire up your chop saw, well, why did this happen? Well, what happened was those two, the air compressor was totally fine, the chop saw might be totally fine, running together, they pull enough current that it's over what the circuit breaker is rated for and it'll trip. So how do you fix that? You run one at a time. You shut your air compressor off and you run your chop saw. That's a really easy one. A lot of electrical issues are not this easy to find a root cause for. You know, if you're operating a piece of machinery and a fuse blows, don't just throw a new fuse in it and go back to work. Call an electrician. Get somebody to actually investigate why that happened. As noted before, circuit breakers and fuses are low resistance faults. There usually needs to be quite a bit of current to trip them, which makes them less than optimal to rely on for worker safety. And what I mean by that is a lot of times there's enough current loose before that circuit breaker or fuse blows to kill you. 50 milliamps across the heart, circuit breakers, fuses, they're not that sensitive. So there can totally be enough current loose to kill you and not trip the circuit breaker. Electrical tool protection, grounded tools versus double insulated tools. So grounded tools, most electrical equipment we use incorporates an external ground connection to protect the user. That would be, on an outlet, that would be the third prong at the bottom. Example, stationary equipment, ironworkers, saws, most stuff we've got in the shop, and metal cased hand tools. Less common now, but they're still in circulation. Like a lot of the old drills were metal cased. The problem with metal cased tools is that if a wire gets loose, like if a wire comes loose from the switch and contacts inside of the case, the entire case is electrified. And because of that, it has to have ground to get that electricity to ground and blow the circuit breaker. If an electrical device uses a grounded plug, a three-prong plug, it must be used with a grounded three-prong outlet or cord. I've seen people needing to plug something into a two-prong outlet, and they will break the ground prong off of it so they can plug it in. That's a really good way to electrocute yourself. Do not alter any of that stuff. Double insulated tools. So most modern portable tools are double insulated, which means they're designed not to conduct electricity to the user if there's a fault in the tool. Double insulated tools come from manufacturer with two-prong outlets generally. I put another sentence in at the bottom that is superfluous, I see now. They don't require external grounding to protect the user. The way they're built, the double insulated tools typically have plastic cases and switches, which are non-conductive. So even if a wire comes loose, the grounder just stops working. It doesn't electrify the case and kill you. And again, double insulated tools typically have two-prong plugs, so they don't need an external ground. Last thing we're going to talk about is tools for hazardous locations. So some environments are not safe for normal electrical tools to operate, usually because of flammable or explosive gas atmospheres. And these environments require special tools. There's two types. One is intrinsically safe, the term intrinsically safe. Intrinsically safe tools are designed not to allow the release of electricity outside of the tool. They're used in environments where a spark might cause a fire or explosion. If you look at a lot of the stuff that firefighters use, their flashlights, pretty much all their electrical stuff is intrinsically safe because they're often could be operating in a flammable environment. Explosion-proof tools, they're designed to contain sparks, fire, and explosions that could possibly cause a fire or explosion if they escape the tool. So, if you've got something with lithium batteries in it and it's an explosion-proof tool, the casing is designed so if those batteries come apart, it's not going to escape the tool. But you have to remember, both of these tools must be inspected regularly and maintained in order to keep their safety features intact. If these tools are neglected or worn parts are not replaced, they will no longer be intrinsically safe or explosion-proof. So all these things that are sealed, you have to get them apart to service them and to change batteries and stuff like that. So there's a lot of wear items in there. There's O-rings that'll wear, seals that'll wear. You've got to inspect that stuff and replace them as needed. So wrap up, electrical grounding is there to keep us safe. Make sure grounding is in place and it's not been modified. Never open or attempt to repair an electrical enclosure unless you have the proper training and are authorized to do so. GFCI outlets can help reduce the chance of serious electrical injury, but they must be working to be effective. When a circuit breaker or fuse blows, find out why it happened. Don't just reset it or install a new fuse and go back to work. Tools we use need to be either grounded or double insulated in order to be safe to use and intrinsically safe, and explosion-proof tools are needed in flammable explosive environments, and they do require maintenance. I'm going to back up a little bit and make sure I didn't miss a slide. I did not miss a slide. Okay, that's it. I will see you in class.